Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over a couple of practice problems that involve constant volume calorimetry, or in other words, bomb calorimeters, where the volume is held constant. And so in these problems, because the volume is kept constant, then the loss of the energy from the reaction is going to be gained by the calorimeter itself and only the calorimeter. So all we need to do is find the amount of heat absorbed by the calorimeter, and that is going to be equal to but opposite to the heat emitted by the reaction that's being combusted or burned in the bomb calorimeter. And so let's look at the first problem. The first problem, we're given 1.010 grams of sucrose, and here's the formula for sucrose. Sucrose, this amount of sucrose is burned in a bomb calorimeter, and so the temperature starts at 24.92 degrees Celsius, and at the end of the reaction, the temperature in the water inside the bomb calorimeter becomes 28.33 degrees Celsius. And so we are being asked, what is the change energy for the reaction? And so this is going to be in kilojoules per mole, and we're given the specific heat of the calorimeter. So one of the things I want to point out is we need an equation to help us find this answer. And so if we notice, we'll notice that the units of the calorimeter constant, or the specific heat of the calorimeter, is in kilojoules per degree Celsius. So we're trying to get the energy of the reaction, the change in energy. We need an energy unit left over. So here we have kilojoules, which is an energy unit, but it's divided by the unit of temperature, which is in this case going to be degrees Celsius. So in order to get the energy unit by itself, you need to multiply by temperature, or in this case, a change in temperature. So that's going to give you the formula you need. So the change in energy, or if we go this way, we could say the Q of the calorimeter is going to be equal to the specific heat of the calorimeter multiplied by a change in temperature. So then we can use the calorimeter constant, or the specific heat of the calorimeter multiplied by the temperature change. That's going to give us the amount of heat that is absorbed by the calorimeter itself, and that amount of heat is going to be the same as the heat evolved by the reaction. Okay, so so we're given the calorimeter constant, so this is going to be equal to 4.90 kilojoules per degree Celsius. We got the temperature change, which is final minus initial. So the final temperature is 28.33 degrees Celsius. The initial temperature is 24.92 degrees Celsius. And so if we calculate this, we'll get the amount of heat absorbed by the calorimeter. So here we have 28. So we got 28.33 minus 24.92 equals, and that's going to give us a, let's rewrite this, kJ over degrees Celsius. This is going to give us a 3.41 degrees Celsius difference in temperature. We'll notice that this is positive. And so what you'll notice is that, again, since we're subtracting, we're interested in the number of decimal places. So they both have 2 decimal places. So we need to make sure we have 2 decimal places there. Now we're going to multiply. So this has 3 sig figs, this has 3 sig figs. So our final answer should have 3 sig figs. So we multiply that by 4.90 equals, and you'll notice that the degrees Celsius cancel out, leaving us with kilojoules. So this is going to give us 16.709 kilojoules for the amount of heat picked up by the calorimeter. Now, the amount of heat, this is going to be, remember that Q of the calorimeter, negative Q of the calorimeter is equal to Q of the reaction. So they're equal and opposite. So the calorimeter is positive, which means that Q of the reaction is negative. So this is negative 16.709 kilojoules released by the reaction. Again, we need to limit ourselves to 3 sig figs, so we are going to limit ourselves to negative 16.7 kilojoules. And again, since the only thing going on in the change in energy is going to be the heat. So the heat of the reaction is going to be equal to delta E, the total internal energy of the system. So that would be your delta E of the reaction. Your delta E of the reaction is going to be the same as the heat evolved from the reaction. Okay, what about problem number 2? So problem number 2 is a combustion of toluene. So in this case, we're using a bomb calorimeter, and we're going to I forgot one more thing. So very, very important here, I almost forgot, is we're looking for kilojoules per mole. Okay, so we have not found kilojoules per mole, we found kilojoules. So we need to find moles of our sugar. So we're gonna have to do a separate calculation here, 1.010 grams and over 1. And then we're gonna have to use the molar mass of our sugar, our sucrose. So if we calculate that, that's going to be, so we do 12.0111 multiplied by 12 plus 1.008 multiplied by 22 plus, and then we have 16 times 11 for the oxygen, and that's going to be equal to, and then it's going to be 342.308 grams of sucrose over 1 mole of sucrose. So grams of sucrose cancel out, and then we do our calculation, 1.010 divided by that number equals, and so this is going to give us 0.0029505 moles of sucrose. So then we're going to take this number and divide it by this number here. So we got negative 16 we'll use the 709, so we don't get a rounding error, divided by this number. And here we get finally 5,662.9944 kilojoules per mole. Once again, we have to keep track of our sig figs, right? So here we had 4 sig figs. Here we have 6, so the answer here should be 4, so we'll keep it there. So that's our 4 sig fig. We divided by this, which was 3 sig figs, based on what we had done before. So, or at least this was divided by this. So this was divided by this, so the least number is going to be 3 again. So 566, so we got to end it there. So our final answer is going to be 5,660 kilojoules per mole. So per mole of sucrose burned, we get 5,660 kilojoules of energy. So that's the first problem. I hope you enjoyed this problem. I'll do the next problem in the next video. If you like this video, if this made sense, go ahead and hit the notification bell so you get more notifications for more videos from me. If you like this video, share it with your friends. Make sure you hit the subscribe button and make a comment in the comment section and let me know what you think and if there's anything else you want me to cover, any questions you want me to answer. Thanks for joining me, and I'll see you next time.